So this is going to be then part 2 of the line balancing problem that we were looking at. So far we looked at shortest processing time, but we didn't have a very high efficiency. So we want to see if we can improve the balance within the stations by using another one of the rules. So let's use longest processing time this time. So our rule will be longest processing time for entry of the tasks into each of the stations. So as before, the first one is task A, and no question about it, it has to show up in station 1 because no other jobs can be started, and at least until A has been done. So A is in. All right, now let's look at our candidates. So I'm going to mark A is in, and then let's mark our candidates. So our only options are B and C. Nothing else can go in due to the precedence of the tasks. So let's see, using the longest processing time then, we have B at 30 and we have C at 50. So we're going to choose C. C cannot go into station 1 because that would be 40 plus 50, it would be 90, and we exceed our takt time of 60. So we're going to have to start in a new station. And oh, one thing we do want to check though is if, and only if that 50, we tried C and that's 50. Okay, well, no, cannot do that. So then we can go to a second option. Well, then what about B? Will B fit in? And no, B still exceeds, because if we instead put B in, that would be 30 and that would be 70. So cannot do it. So we're going to take C then, our longest processing time choice, and move that to station 2. So, or assign it to station 2. So now that's in there at 50, and let's say, okay, that's done. And then let's look at our candidates. So B is still a candidate, but now we have F and G as candidates as well. So let's take a look and see what can go into station. If anything will go into station 2. So B is 30, F is 40, G is 15. So longest processing time, put F in. Well, F can't go because that would be 90. So let's look at the next longest one, 30. So can 30 go in? No, because 50 and 30 would be 80. Can't do it. Well, can we put G in? Our third longest processing, the third in the order of longest processing time? No, it still can't go in. So we're done with station 2 and we move to station 3. All right, so longest processing time says B 30, F 40, G 15. So we're going to put in F because it's the longest processing. That is 40. Okay, so now let's mark that one as in and see if it opens any more candidate tasks for us. Well, no, H can't go in until D and E are done. So we've got for candidates, we have B and we have G, B and G. So we want to use longest processing time, and B would be our choice because B 30, G 15. So B at 30 would be 70 too much. So, well, what about G then? The second in line of the longest processing. And can we put G in? And G does fit. So we go ahead and move to G only because the one above it would not work. So now we've got 55 in station 3. So let's tag that one as G is entered and accounted for. So that opens up another candidate for us, which is I. So now let's go to our longest processing time and look at the candidates. So we've got B and we have I. And we want to choose the longest processing time. So we're going to put B in. Well, B doesn't fit in station 3. That would go over. So B will move into station 4. Can we put, before I do that, I'm sorry, let me check. Let's just check. So I want to put the longest processing time. So I want to put in B, and that is 30. Too much, can't do it. All right, so what about the second in line, 18? So can I put I in there at 18? And the answer is no, that exceeds 60. So can't go to that one. All right, so move to station 4. Move to station 4. And so the candidates didn't change, it's B and I. So put in the longest processing time, that's B. So B is going to go to station 4, and we said B is 30. All right, so let's make our adjustments. So B is done, which opens now D and E as candidates. So right now we've got 3 candidates, D, E, and I. Using longest processing time, choose D at 40. So we try to put in D, but at 40, that 70 exceeds. All right, what about the second in line? Well, we've got after D, the next choice would be I. And does I fit? So I fits at 18. So I goes in. So we're at 48. So let's mark I as in and see if it opens any more candidates. Well, it doesn't, because we can't go to J till H is complete. So our candidates are still then D and E, but we know we already tried D. D can't go in. So, but can E go in? Can E go in? Since it would be the second in line. First in line D, but first in line is D. That's our first choice. Longest processing time exceeds 60. Can't do it. What's the next in line? Well, that's E, and it is 6. So can that one stay in? And yes, we don't exceed 60, so E can go in that station. So let's mark. So there's E, it's in. And so that doesn't open up any more candidates. The next one is, that has to go in is D, and D cannot go into station 4. So D starts a new station. So there's 40. Okay, so let's put in, mark D is in. And now our candidate is H. It's our only choice. It's our only choice. So can it fit into station 5? Well, it can. So H goes in here, and that's at 20. So we're at our 60. We're at our match. Our max. So we didn't fit into our theoretical minimum of 5 stations. So we have a 6th station, and then that's where J will go, our remaining station at 30. So using longest processing time, this is the allocation of the tasks to the stations. So let's go ahead and calculate our efficiency. So our efficiency is going to be sum of the task times divided by the actual, not the theoretical, the actual number of stations times task time. So you may recall from the previous video when we did shortest processing time, we had 7 stations. This time we have 6. So since we're going to be dividing by a smaller number, our efficiency is going to go up. So we had 289 seconds, we had 6 stations, and a takt time of 60. So let's figure out what that's going to be, even though we know it's going to go up. So 289, 6 divide, and 60 divide. So that gives us 0.8028, or an efficiency of roughly 80.3%. That is definitely an increase from using the rule of shortest processing time. And then lastly, let's calculate our balance delay, which is 1 minus the efficiency. So that's going to equal 1 minus 0.8028. So that is equal to 0.1972. So our balance efficiency, I'm sorry, our balance delay went down as well. So that's a good thing. And let's just take a look quickly at our stations. So we had, and I'll write it in red, we had 40, we had 50, we have 55, we have 54, 60, and 30. So you could look back and compare that to the stations, the amounts in the stations using shortest processing time. And we should see a better balance. Work is going to move in a more balanced manner. So that, in summary, then, is using longest processing time. So I'm going to go ahead and stop the video, and then I will make another one for most number of following tasks and least number of following tasks.